Okay, so like I said, we're finally ready to begin our very first lesson of the grade 11 curriculum. And we're going to be talking about something called rational expressions. Now, you've heard both of those words before. The word rational describes a fraction. So whenever you have a numerator and a denominator, that is a rational. And the word expression is what you describe when you have something that is like an algebraic expression, something with two terms like a binomial, three terms like a trinomial, many terms like a polynomial. So for all of these questions, we're going to have a fraction where the numerator and or denominator are polynomials. And just skimming through the sheet, you can see that all of the questions we have are fractions. You have a numerator and a denominator, and they're not fractions like we're used to seeing, like 3/4 or 5/8. They have a polynomial at the top and a polynomial at the bottom. Just another note, restrictions, that's a word that I'm going to describe a lot of. I'm going to tell you the definition, but then when we actually get down to doing the questions, it'll make a little bit more sense. Restrictions are the values of the variables that cause the expression to be undefined. And like I said, I'm going to wait on that and I'll explain it a little bit more when we get into the questions. So here are the 4 steps to simplifying rational expressions. The first thing we're going to do is we're going to factor anything that can be factored, which is great because we're just going to get more factoring practice for our quiz tomorrow. Then we're going to simplify monomials using the exponent rules. And we should cover those right now. So let's just go over to the side and talk about what our exponent rules were in grade 9. So do you guys remember when we had something like x to the power of 3 times x to the power of 2? When the bases are the same and there's a multiplication sign, what do you do with the exponents? Marzouk? You're going to add them together and you're going to get x to the power of 5. How about if you had a division question? So y to the power of 6 over y to the power of 4. What do you do in this case? Yep, Ben? You subtract and you're going to get y squared. And then you can have a power of a power. So y to the power of 3, all to the power of 5. What do you do for this exponent rule? Sarah? Yep, and you're going to get y to the power of 15. Now, I just want to make note what happens when you have a division question, but the exponent at the top is bigger than the exponent at the bottom. So for example, what if I gave you y to the power of 4 over y to the power of 6? Yep, Janitza? Yeah, you can write it in 2 ways. And so it can be 1 over y to the power of 2. Or another way to think about it is it's just y to the power of negative 2, which is the same as y to the power of 2, right? Because 4 take away 6 is negative 2. And I don't know if you remember this, but if you have a negative exponent, to get rid of that negative exponent, you make it a fraction where you have a numerator of 1, and then you have a denominator of whatever is left. So in whichever way you decide to do it, you're still going to get an answer of 1 over y to the power of 2. And this rule is quite important for all of the questions we're going to do. Jeff? Yeah, we don't want any negative exponents. So we're definitely going to be writing it as 1 over y to the power of 2. Okay, so just remember these exponent rules while we're doing these questions. You got it right, Wasif? I'll just pause here because I see some of you are still writing this. Okay, let's go back to the rules that we had over here. Rule number 3, eliminate common binomial factors. I'll explain what that means. And then rule number 4, write what's left. Now you're going to notice on these sheets, there are a lot of questions. It's a little bit of overkill. So I'm just going to select a couple to do. We're probably not going to do all 24 because like I said, it's just going to get a little too boring. Let's start with question number 1. We have a monomial at the top and then we have a monomial at the bottom. And we're trying to simplify this. Just like when we used to simplify fractions, it's the same concept. So we're going to begin by looking at the numbers. 12 over 48. What can I divide the top and the bottom by to reduce that fraction? Rahiman? 6, good. There's another number that's a little bit bigger. Tanisha? Yeah, we can divide both the top and the bottom by 12. 12 divided by 12 is just going to give me a 1. 48 divided by 12 is going to give me a 4. And by the way, if you did pick a number other than 12, you would have still gotten the same answer. It just means you would have had to reduce it one more time. Okay, so our fraction ends up becoming 1/4. Now we're going to use our power laws to figure out the rest. We have y over y to the power of 3. If we think about that, that's like saying y1 over y to the power of 3, which is 1 take away 3 is -2. And that's the same as 1 over y squared. Another way to think about it is I have 1y at the top. So here I'll write it like this, 1y at the top. Can I just say, I feel like every time I write, it erases. And I don't know why it's doing that. Maybe I press the button. 1y at the top, and I have 1, 2, 3 y's at the bottom. And when I reduce, I'm basically crossing out these y's, and I only have 2 y's at the bottom. So if you're a visual learner, that might help you understand why it's 1 over y to the power of 2. If you like the algebra part of it, you're just taking the exponent at the top and subtracting the exponent at the bottom to get you -2, and then you convert it into a fraction. So either way, our y to the power of 2 is going to go at the bottom in the denominator. And that's it. That's your final answer. Does that make sense? Question? So because these are monomials, we're not even factoring anything. We're just reducing the fractions, and then we're using our exponent rules to simplify the variables. When we get to question 7 and forward, then we're going to start factoring. So for this question that we just did, I would say that we skipped step 1. We just did step 2. Yeah. Okay, let's skip over to question 3. So 8 over 24, what can I divide the top and the bottom by? Yep, 8. So I'm going to get 1 over 3. And then when you have multiple letters, you just do them in order. So let's look at our m's. We have m squared, and then we have m to the power of 1. So what letter are we going to be left with? And is it going to go at the top and the bottom? Denisa? Exactly. And the reason for that is m2 minus 1 gives me just m to the power of 1. And that is just a regular exponent. It's not a negative exponent, so it stays in the numerator. The general idea is if you subtract something and you get a negative exponent, that always goes in the denominator. If it's a positive exponent, it stays in the numerator. Let's look at the next one. So we have n1 divided by n to the power of 3. That's like thinking 1 take away 3, which is -2. So where do you think that's going to go, Marzu? Say that again. Yep, that's what I'm doing. You're talking about question of 3, right? I'm still on that one. Yeah. So I'm saying n to the power of 1 divided by n to the power of 3. Yeah. Marzu? At the bottom. Good. And the reason we knew it was at the bottom is because 1 take away 3 is -2. A negative exponent, to make it positive, you move it to the denominator. This is making sense? Yeah. All right. Let's do question 5 to finish off these questions. 12 and 40. What can I divide both of those by? Sarah? 4? Yep, and that would be the lowest one. So we're going to get 3 over 10. A squared divided by a to the power of 3. What exponent are we left? And what are we left with? And is it at the top or the bottom? Bea? A at the bottom. Good. And then b to the power of 3 divided by b to the power of 1. Then b squared at the top. I'm just going to show you one other way, just in case you didn't understand the examples we did. Just one other way you can think about it if you're ever confused. So let's just look at the question we just did. A squared and b to the power of 3. That's like saying a times b times b times b. And then a cubed and b is a times a and b. So all I did is I took all the exponents and I wrote them out the long way. And now you just start crossing things out. So you find a matching pair, cross it out, find a matching pair, cross it out, find a matching pair, and cross it out. What are we left with? We're left with 2 b's at the top, 1 a at the bottom, which is why it's b squared over a. So if you don't understand exponent rules and anything like that, then just write it out start crossing out matching pairs, and whatever you're left with ends up being the answer. All right. Let's get into the harder questions, the ones with the binomials. And I think I will do all of the questions on the right. So let's do 8, 10, 12, and 14. So now for these questions, whenever you have a binomial, you have to start with step number 1, which is factoring it if you can. All right, so let's start by factoring the numerator and factoring the denominator. I see we have a common factor of 4. And we're going to be left with x minus 1. Everyone see how I did that? Okay. And this is, by the way, why we were emphasizing factoring so much, because if you don't know how to factor, then all of these concepts in the first unit of grade 11 are going to be impossible. You have to be pretty good at factoring to be able to see what you're supposed to factor. Then at the bottom, we're going to have a common factor of 4. And then in the bracket, we're going to have x plus 1. Okay, this now leads me to a very important concept in math that a lot of people don't get correct, and I want to clarify it. If I have something like this, a plus b divided by b, am I allowed to cross out the two b's? The answer is no. It is very, very wrong to do that. You are not allowed to cross out anything when there's an addition or subtraction sign. Okay, how about if I have b times a plus 1 over b? Am I allowed to cross out these two b's? Yes, I am. And the reason why is you can cross things out when they are multiplied together. So in this case, it's b times a plus 1 divided by b. That b is sort of all by itself. It's not inside the bracket. And then you have the b at the bottom. You are allowed to cross those out. Let's do one other scenario. What if I gave you something like a bracket 5 plus a over a? Am I allowed to cross these a's out? Yes. Can I cross out these a's? No, you can't. So again, because there's an addition sign inside the bracket, you're not allowed to cross those a's out. You can, however, cross these a's out because that a is separate from the bracket and it's multiplied. Anything multiplied, you can cross out. This is a super important rule. In grade 9, I always said anything inside the bracket is protected. It's like there's a barrier, a wall. You can't touch anything inside the bracket. So now going back to this question that we were working on, what can I cross out here? Yeah, I can go ahead and cross out these two 4s. And then I can see what's left over, which would just be an x minus 1 over an x plus 1. Can I cross out the x's in the brackets? I cannot. Good. That's it. Super straightforward, right? Yep. At that point, you don't have to leave the brackets in. No. Okay. Now we have to state something called the restrictions. And I actually should have stated the restrictions for the previous couple of questions. Let me explain what restrictions are. Okay, again, I'm going to go to the side over here and we're just going to talk. Are you allowed to have a fraction that looks like this? Can you have 0 over 6 as a fraction? Is that allowed in life? Are you sure? Let's say I have 6 slices of pizza and I decide to share them with no one. So this is kind of like saying 0 out of 6 people are going to get the pizza. Is that allowed to happen? No, you can't do that. Why not? You can, right? If I have 6 slices of pizza and I share them with nobody, that means 0 people get the pizza. This is allowed. Yep. No, so the number at the top is how many people are getting a slice of pizza, and the number at the bottom is the total. So actually, 0 over 6 is a fraction that you are allowed to have. Another way to think about it is I have a pie chart with 6 slices. So like that, 1, 2, 3, 4, 5, 6. Oh no, I I made it 8. Okay, we're gonna change it. I am not gonna change the drawing. We're gonna change the question. I have 8 slices of pizza. I'm not gonna give anyone anything. So you're basically just gonna have 0. Okay, are you allowed to have this though as a fraction? This is like saying 8 people are getting 0 slices of pizza. This will give you an undefined answer. If you try to put this in your calculator, it'll end up being an error. You are never allowed to have a denominator that is a 0. It's not allowed in math. It is super illegal. It just is errors all over the place. So you are allowed to have the scenario at the top. That's all fine. You can have a 0 at the top. You cannot have a 0 at the bottom. So this is what leads me to a restriction. A restriction is you're thinking about what this x in this question is not allowed to be, because if it became that specific number, then the denominator would become a 0 and the whole entire question would become undefined. Can you think of a number to put in this x that would make the denominator undefined? Deepika? -1, good. And how do we know that? Well, we know -1 plus 1 is 0. Now, instead of you having to think about that all the time, I have a really easy way to actually calculate this. And I'm going to show it to you right now. So I'm going to call this the restriction. And I know you guys don't have a lot of room, so you're just going to squeeze it in somewhere. And to calculate the restriction, what you're going to do is you are going to take the denominator and you're going to say the denominator cannot equal to 0. So x plus 1 cannot equal to 0. And then you're going to solve that just like you solve an equation. So see how I have a positive 1 over there? I'm going to move it to the other side, and it's going to be x cannot equal to -1. And that is your restriction. Now, as we do enough questions, you're going to notice that you don't even really need to show all that work. You can probably figure it out on your own, and you don't actually have to show any work when you're doing this. But for the first couple of questions, we will do it the long way, just so you can get used to figuring out what the restriction is. Let's go back to the previous questions. Can I figure out the restriction here? So in question number 1, what is y not allowed to be? Because if you made y this number, it would become undefined. For question number 1. Yeah, you're right. So the restriction in this case would be y cannot equal to 0. It can be any other number in the number line, except you can't let it be a 0, because if y was a 0, then the bottom number would become a 0 and the entire thing would become undefined. Rahima? Yes, yes, you have to put the restrictions in. I know. Like, where'd this come from? Okay, let's try question number 3. What's the restriction there? Rahiman? 3 is 3. You were close. N is not allowed to be 0. Yeah. Do we care if M is a 0, the letter M at the top? We don't care. That can be a 0 all at once. The numerator is allowed to be a 0. The denominator can't be. Okay, how about question 5? What do you think is the restriction for question 5? What can't be 0? Yep, A is not allowed to be 0. And I always save the restrictions for later on when we kind of understand what's happening. So now I'll remember to put them in every question. Yep. Okay. All right, let's keep going. Let's try question number 10. So we're going to begin by factoring the question. We can't do anything with the numerator. The bottom is a difference of squares. So go ahead and factor that. Oh, I changed it to an x. It should be a z. And I got z plus 1 in the numerator. In the denominator, I got z plus 1 times z minus 1. Now, do you notice that all of these brackets at the bottom are multiplied to each other? So are we allowed to cross terms out like this? The answer is yes, you can. You're allowed to cross out entire brackets because the brackets are all multiplied together. What you're not allowed to do is cross out little individual things like the x and the x. You're not allowed to do that because it's protected inside the bracket. However, you are allowed to find binomials that are matching, which is honestly the best part about these questions because it's so satisfying. You are allowed to cross those out. Then what you're left with is just going to be 1 over whatever other bracket there is. Do you need to keep the brackets? Nope. It's just, I do it. I don't know why. All right, let's state the restrictions. Now, if you're wondering, do I state the restrictions before I started crossing things out or the simplified version? The answer for that is you state the restrictions before you started crossing anything out. Denisa? Yeah. I crossed out the 2 that were matching. So both of them are Z plus 1s. They're not the same. So you know how in the previous question we canceled out the 4 and the 4 because they're exactly the same? You can only cross out brackets that are exactly the same. Sarah? No, Mark? Yep, Marzu. Well, when I cross something out at the top, that doesn't mean there's a 0. It's not like that nothing exists. It just means that you replace it with a 1. It's kind of like 4 divided by 4 gives you a 1. 6 divided by 6 gives you a 1. So z plus 1 divided by z plus 1 leaves a 1 at the top and the bottom. Yeah. Are we okay? Okay, let's go ahead and state the restrictions. And like I said, we are going to state the restrictions for the step before we start crossing things out. So it's going to be for this over here. Okay, I have z plus 1 and z minus 1. You could do it the long way and calculate everything, or you could just look at it. What do you think are the restrictions? Like for z plus 1, what can we not let z be? Minus 1. And how about z minus 1? What can't we let z be? Positive 1. Yep. So all I'm going to say is z cannot equal to -1 and 1. Commonly, the format is when you're stating your restrictions, you are doing it from smallest to largest. I find that your textbook often does that. So I try to do that as well, where I'm going to write the -1 first, and then I'll write the +1 after. Oh, I don't know what I did there. Let me try that one more time. And again, what are restrictions? Restrictions are just numbers that make the denominator a 0. And the reason why we're trying to avoid that is because if the denominator becomes 0, it's undefined. Marzu? So you're saying, why didn't we do them for the simplified version? It's because if you were to do it for the simplified version, you would only get +1. But in the original question, +1 is not the only restriction. So really, you're actually stating the restrictions for the original question. If you substitute that in, it's not the only restriction. Okay. All right, let's try question 12. We're probably getting a little better at this, so we can do it faster. Yep. Yeah, I always use the very first step after I've factored everything to figure out my restrictions. Oh, you could, except see in this question number 12, m squared plus 2m minus 24, you're going to have to factor it anyways to figure it out. So that's why I always do it with the step where I've factored it. All right, so go ahead and factor that. Yeah. You're going to get some practice factoring a simple trinomial. So I got m plus 6 in the numerator, and then at the denominator, I got m plus 6 and m minus 4. What can we cross out? Good. And by the way, these questions will always give you something where you can cross them out. If you find that you can't cross anything out, you've probably done something wrong. And so your simplified answer is going to be 1 over m minus 4. Okay, let's state the restrictions. to do that, I'm going to go to the part before I cross anything out, and I've factored everything. So that step over there. And I'm just going to write m cannot equal, what two numbers can it not equal? Bea? And? Good try. Look at the bracket that we crossed out, m plus 6. Yeah, so I'm going to say m cannot equal -6, comma 4. And that's really all you need to write for your restrictions. You don't have to write the word restrictions or anything. That's it. Are we getting the hang of it? Yeah. Yep. So the long way is you take each one of these brackets. I'll show it to you over here. Let's say we look at the first bracket. M plus 6 cannot equal to 0. So m cannot equal to -6. Then I look at the second bracket in the denominator, which is m minus 4. So m minus 4 cannot equal to 0, which means m cannot equal to 4. So that means if I put in a -6 in the first bracket, that equals a 0, and then now the whole denominator is a 0, and the rational expression is undefined. So we cannot let m ever be -6 in order for this to stay a valid answer. The same thing for 4. If I put in a 4 into the second bracket, 4 take away 4 is 0, and then the denominator is undefined, which is really bad. That makes sense? What part does it? Okay, so I'll show you. Understand factoring? Nothing is hard. All right, let's try another one. For question 14, this time we're factoring the top. So we have another simple trinomial. It's going to be r and positive 10 minus 1. And then this will be 3 and then r plus 10. Did you guys get that when you factored? Or maybe I went too fast and you hadn't factored yet. Yeah, sorry, I'll slow down. But when you guys give me time, then I just start formatting. Oh, I can do attendance. Let me pause the recording. Okay, so I'm going to cross out my r plus 10 and my r plus 10, and all I'm going to be left with is r minus 1 over 3, or just over 3. What are the restrictions in this question? What is r not allowed to equal? There's only just one. Nawal? Try again. Why did you get positive 1? But yeah, I think you see your mistake. You want to fix it? Yeah, it's at the top. So you're only looking at the denominator, r plus 10. So, Robaro? Yeah, do you see why it's minus 10? Yeah, okay, good. So the only restriction is r cannot equal to minus 10. Okay, let's go on to the second page. I guess 5 questions is not that bad. We're making good time. So we're gonna do all the questions on the left again. Actually, let's change it up. Let's do all the questions on the right. Okay, so now it's getting a little bit more complicated. You have trinomials on the top and the bottom. That's okay. We're just going to go ahead and factor everything and see what we get. Yeah, I don't like questions like 15 because nothing crosses out, which is very not satisfying. I personally like when things do cross out, and you're going to notice in the practice questions they will. But I just got x plus 6. Oh, you know what? I messed up. It should be x plus 3. It should be x plus 3 and x plus 2. You're right. So then things do cross out. Yes. I take everything back. So we're going to get x plus 3 at the bottom, at the top, and x plus 4 at the bottom. And then for my restrictions, x cannot equal to -4 and -2. Okay, so let's do you guys mind if I like mix and match? Let's skip over to question 19 because really those are all the same. Let's do question number 19. For question number 19, it's not a trinomial, so all you can do is take out a greatest common factor. So for the first one, I'm going to take out 8x squared, and I'm going to get x plus 1. And then for the bottom part, I'm going to take out 10x, and I'm going to get x plus 1. Marzu? That's why we did all those factoring question practices. Sometimes you'll just have to try every strategy you possibly can. And then of course, you guys remember from grade 10, there's also the quadratic formula. So if like you're really, really, really stuck, you could try the quadratic formula to see if it works. But generally, if we're giving you rational expressions, things will be able to factor. I'm going to cross out the x plus 1 and the x plus 1. And now I'm left with a monomial that I can simplify. This is kind of the practice we did right in the beginning. So 8 over 10 is going to give me 4 over 5. And I have an x squared over x. So I'm just going to have an x at the top. So this will just reduce to give me 4x over 5. You guys, what are the restrictions for this? Oh, this is an interesting one. We haven't done one where it's just an x by itself. Sarah? Yes. So -1 for sure. When you have an x all by itself, the restriction for that is x cannot equal to 0. So we're going to state it as x cannot equal to -1 and it cannot equal to 0. What's that? Oh. All right, now let's try question number 20. Because that one is a complex trinomial. We haven't done one with a complex trinomial yet. So go ahead and factor the top and the bottom, and then we'll see what we can cross out. Okay, I'm not going to mess up the factoring this time. I'm going to factor out a 5. We're going to get y squared minus 2y minus 8. I lied. It's not a complex trinomial. It's just a greatest common factor. Oh, I can just sense that it's dying again. Oh, never mind. We're still good. Did I make any mistakes? We're okay? All right, what? Yep. Oh, I did make a mistake. You guys didn't see it. There's a plus sign there. It should be a plus and a minus. I hope you guys know I make those mistakes on purpose just to keep you on your toes. Question? Okay, yeah. So definitely did make a mistake there. I'm going to cross out the y minus 2 and the y minus 2. This will become a 1 and this will just become a 2. And so my final answer is going to be y plus 4 in the numerator. And then in the denominator, I'm going to have 2 bracket y minus 1. Yeah. I reduced them to 1 over 2. Yeah. And then we're going to also state our restrictions, which is going to be y cannot equal 2. I go to the step before I cross things out. So what do you think are the 2 restrictions in this question? Tanisha? Yep, so I'm just going to write it as a 1 and 2. Let's do one last question to end this off. Doesn't matter, they all kind of look the same. So let's do either 22 or 24. How about we'll do 24. 22 and 24 are complex trinomials, so we get the same practice with those. Nope, this is going to be 2 actually. Oh, and we haven't gotten a restriction where it's a fraction, so I'll just pause here. So I wanted to talk about the restrictions here because we haven't seen something with a complex trinomial. Nothing changes, and you don't even have to show your work for it if you can do it in your head. But just so I can show you the process behind it, I'm going to take the bracket 2y plus 1, and I'm going to say it cannot equal to 1. Sorry, cannot equal to 0. And then I'm just going to move things around. So I'll move the 1 over to the other side. It's going to be 2y cannot equal to negative 1. How do I get rid of that 2 besides the y? Then, yeah, I'm going to divide both sides by 2. So y cannot equal to negative 1 over 2. The next one is 2y minus 3 cannot equal to 0. So 2y cannot equal to 3. And y cannot equal to 3 over 2. So my 2 restrictions for this question are y cannot equal to negative a half, and I cannot equal to 3 over 2. What do you guys think about that lesson? Is it pretty straightforward? Yeah, kind of enjoyable? It's a lot of stuff to remember. You guys have that one page. And for this sheet, you're going to notice there are no questions, but I'm actually going to post the answers on Brightspace. I just warn you that the answers on Brightspace actually don't have any of the restrictions on them, but I do want you to write the restrictions for all of the questions. And then there are also some textbook questions on page 112, numbers 1 to 5, 8 to 13. Do as many of it as you can. I know you have a quiz tomorrow, so you might be focusing on that. And then we're going to just continue on with this topic in tomorrow's class.